At this point, we have the list of all the images that we want to upload to Firebase, and we've downscaled them appropriately. And we are now converting them into a byte array, which is what Firebase will take in the upload process. So in this segment, we're going to write the core logic for taking these photos and actually uploading them to Firebase Storage. This will obviously require the use of the internet in order to communicate with our client, our Android device, to Firebase Storage. So let's open up Android Manifest and add in the internet permission. One thing to observe here is that internet is a normal permission, while read external storage is a dangerous permission, which means that we don't need any of the runtime permission logic that we needed for read external storage. We get internet permission for free. In order to now upload this into Firebase, we need to have a new Firebase project. So what you should do is go to console.firebase.google.com. Let's tap on Add Project. And let's call this project My Memory. Continue. And then let's disable Google Analytics for now. It's not strictly required for what we're building. And now Firebase will take a couple seconds in order to build out your Firebase project. All right, so we're done. Let's tap on Continue. And we're going to add an app, an Android app, to get started. So we're going to associate our Android app to this Firebase project. So for the package name, let's go back into Android Studio, go up to the very top, and then here is our package name, which is the thing that we had defined at the beginning when we were creating a new project. Copy that. I'm going to leave the rest of this blank, just say register app. And now we need to download this file, googleservices.json. And what we want to do is we want to actually drag this into the app directory. So the way we can do this is, as shown in that photo, go into the project tool window, go into the project perspective of your project, and inside of the app directory is where we're going to drag and drop that Google services.json file. So I just dragged it in, and now Android Studio is saying move file over. So I'll say yes, I do want to move this file over. And now we can see we have Google services.json. So now let's go back into the browser and see what else we have to do. So now we have to add in the Firebase SDK or software development kit into our Android app. So in the project level build.gradle file, we want to first check if we have the Google repository, and also in the dependency section, add class path. Well, let's go back into the Android perspective. In Gradle scripts, the one which is in the root level, we already have Google up here, and we also already have Google down here. We just need to add the class path for Google services. Tap on sync now. Now, in the app level build.gradle file, we want to add this line for the GMS Google Services plugin. So let's exit this build.gradle file and open up this one. And here at the top is where we're going to add that. Copy that line, and we have to modify this to match the format. That. And now we need to add the dependencies for whatever parts of Firebase that we want. So Firebase actually has dozens of services within it. We're going to only really need a couple of them. So I'm going to copy this line for the Firebase bill of materials. So we added that. And now below this, we're going to add the dependencies for whatever products that we care about. So let's open up this URL. There are two products in Firebase that we care about: Firestore and storage. So first off is Cloud Firestore, and make sure that you're actually in the Kotlin tab here. So you get the Kotlin version of these libraries. So we're going to have to say implementation with this library. And then the second product is cloud storage. And the nice thing with including this build of material is that we no longer need to specify the version on each Firebase product that we're adding in. So let's tap on sync now. Now we've pulled in Firebase into our project. Let's go back into our browser, tap on next here, and then tap on continue to console. And here we need to enable the two Firebase services that we're going to integrate into our project. So let's start with storage, and then tap on get started and tap on next. Choose a location which is close to you. So for me, it's US Central. Tap on done. So now we have Firebase Storage set up, go into the Rules tab, and by default, read and write are only possible if there is a logged in user on the client who's doing the request. And we don't have a notion of an account or a logged in user in our app, so I'm just going to set this equal to true. And then if you're publishing this app, of course, you want to kind of be more mindful about who you're allowing to read and write data into Firebase Storage, but for our purposes, this is going to be fine. The other product that we're going to use is Cloud Firestore. So I'm going to create database, and we're going to start this in test mode. And test mode basically is something similar to what we just did. It's saying that anyone can read and write to our Firestore database as long as the timestamp of the request is within a month. So for the next 30 days, anyone can view, edit, or delete data in our database. And again, we're going to pick the same location. Perfect. So now we have our two products set up, Firestore and Storage. I wanted to spend just a couple minutes describing how Cloud Storage and Cloud Firestore work together in order to allow the user to create a custom memory game in our application. Because this is the most critical part and most complicated part of our application. So when the user creates a new memory game, they're going to pick various images from their phone. And each of them will be stored inside of Cloud Storage. And when we successfully upload something into Cloud Storage, we're going to get back a URL which defines how we can retrieve that image later on. So once we have a list of image URLs for each photo that the user wants to attach into their memory game, we're going to then take those list of image URLs and upload that or push that to Cloud Firestore along with the associated key. So for example, in this case, we have a memory game called Corgi, and Corgi will have 4 unique images associated with that, which is how we're getting 8 memory cards, and that will live in Cloud Firestore. And so now when another user somewhere in the world wants to play this game, this Corgi game, they can type that into the memory game app, and we will pull down all the images from Firestore associated with Corgi. And that'll be a list of 4 different image URLs. And that's how we'll be able to allow the user to play this custom game called Corgi. So the complexity here is due to the fact that uploading these images is an asynchronous operation. So there are 2 kinds of programming. One is asynchronous programming and the other is synchronous programming. So most of the operations that you might be familiar with are probably synchronous. For example, if you're doing 2 plus 2 or any kind of simple arithmetic in Kotlin, or if you're combining strings, those are synchronous operations in the sense that when you execute that, you can expect a result immediately. However, what we're dealing with here is asynchronous, which means that when we execute the operation, we will not immediately find out whether it succeeded or failed because it might take a longer amount of time. Image uploads are a good example because images are inherently quite data rich. There's going to be a lot of data, and uploading that over the internet, anything you do with the internet is going to require more time. And so we're going to start the upload process on all the images that the user has picked out for their custom memory game. In this case, where the user has picked out the Corgi game, and we're going to start uploading all of them into Cloud Storage. And the tricky thing is that the rate at which these images get uploaded is not in our control. So for that first image, it might be halfway done uploading. The second image might be totally done uploading, and so on for the third and fourth. We might have a different rate of uploading. And so the question now becomes, how can we figure out when all of these operations have succeeded so we can record the image URL corresponding to each image that we've uploaded? And the way we'll do this is by getting notified when each image has successfully been uploaded. So as soon as the image reaches Cloud Storage, we'll get a corresponding download URL for that image. And we'll track how many download URLs have we received. And if the size of that list of download image URLs is equal to the number of images that we're uploading, then we know we're done. And so we're going to continue this upload process until we get to this state, which means that all the images have finished uploading. And now we will have a list of image URLs for each of the 4 Corgi images that we have. We're going to combine that with the custom game name, which is called Corgi, and that is what we're going to send to Firestore. That is what we're going to implement, at least partially, in this segment. So let's go back into Android Studio. The first thing we'll do is get a reference to Firebase Storage and Firestore. So at the very top of the file, Kotlin, the library that we included, makes this super easy. We'll just say private val storage is equal to firebase.storage, and then private val db, which represents Firestore. And so going back now to where we have defined this image byte array, our goal is to upload these into Firebase Storage. The way that works is we're going to define a file path on where this image should live in Firebase Storage. And I want this file path to actually be dependent on the game name. So if you ever wanted to look at this from the Firebase console, it'll be easy to tell which images belong together. So custom game name, let's define this as et_game_name.text. And then inside of that directory, let's specify the current time in milliseconds dash the index. And then this will be a JPEG file based on the logic that we wrote in get image byte array. And so the idea here is that if I have 4 images, for example, in the corgi game, then that'll be saved in images/corgi/ the current time in milliseconds dash 0, 1, 2, 3, because there are 4 images. This is a nice way to combine all the images associated with one memory game. So now we have exactly what we need to upload the image to storage. We have a file path and the actual underlying data for this image. So we'll get a reference to the location of where we want to save this photo, which will be storage.reference.child with that file path that we defined. And we'll put the image byte array data at that location. All right, so this is the operation which will actually do this expensive work of uploading the bytes representing the image to Firebase Storage. And so instead of getting the result of this as some return value here, we will instead get a task which we have to now wait for until it succeeds or fails. And so the way we can do this is we're going to say continue with task. And what that means is this is an API defined by Firebase which says this is a long-running operation. Once it concludes, then I want you to execute this code, and I want you to also execute one more task. So we're going to define what that is at the end. But first, the result of this put bytes is a photo upload task. And from here, we can actually conclude how many bytes were uploaded, just to get some more info about what happened. So photo upload task dot result, and then if it's not null, then we can check this bytes transferred field. Okay, and then we have to end this block, this lambda block, with another task. That's why we wrote continue with task. And the task we want to continue with is once this photo has been uploaded, now we want to get the corresponding download URL. Photo reference dot download URL. Now you can see how the error went away. Again, getting this download URL is going to give us a task. And so now we have to wait for the completion of that task. And that's an asynchronous operation. So in order to get notified of that, we'll call add on complete listener. And the parameter here will be the result of this operation that we just triggered. So it'll be called download URL task. And the first thing we want to check is, did this operation succeed or not? So if download URL task if it didn't succeed, then let's log an error. And let's also show a toast telling the user failed to upload image. If any of the images encountered an error while uploading, let's set this as a Boolean flag here. Did encounter error is equal to true. So initially this variable is going to be false. So var did encounter error is equal to false. And then if we encountered an error in uploading any of these images, then we're going to set that equal to true. And if this happens, we're going to do a premature return because there's no point continuing. The important thing to realize is that this add on complete listener will be called for every image which is uploaded. And we don't control the order in which these are called, right? And so if this particular image URL failed to upload, then we'll go into this if block. But if some other image upload failed, then we wouldn't actually know from here. And that's why we actually added this Boolean did encounter error. So if did encounter error is true at this point, that means that some other image has failed to upload. And we again want to just return from the add on complete listener because there's no point in continuing. Otherwise, we have been able to successfully get a download URL. So I'll look inside the task, look at the result, and then cast it to a string, and that will give me a URL. And at this point, now we want to make note of the fact that this image has successfully been uploaded. The way we'll do that is by keeping an array of all the images that have been uploaded so far. So we'll call this val uploaded image URL, and that's equal to a mutable list of a string. So down here, we'll say uploaded image URLs dot add, and we'll pass in this download URL. Now let's put a log statement here saying log.i with this tag, and we'll say finished upload photo URI. So if we think back now to that diagram, how do we know when all the images have been uploaded? Turns out that's pretty easy, right? Because we're keeping a track of all of the images that have succeeded so far in this list, all we need to do is check the size of that list. So if the size of uploaded image URLs is equal to the number of images that the user has picked, then we know we're done. So we'll say handle all images uploaded. So this is, in some sense, the success callback for the images having been uploaded. And from here, in this method, we're going to pass in the game name and the uploaded image URLs. And this is exactly the information that we need, if you remember, to upload into Firestore. So that's what we're going to handle later on, uploading these two key pieces of information into Firestore. Let's rename the parameters here to be image URLs and game name. All right, that was some pretty heavy logic to think about and implement. Let's test it out and see if it works. So one thing I want to do is, right now we're launching the create activity with the medium size board, which requires me to upload 9 images. That's too much for me. I'm feeling lazy. So I'm going to change this to be the easy board size. Rerun the app. So we only have to upload 4 images now instead of 9. Let's tap on one of these images and let's grab these 3. So now we have one more to upload. So let's get this panda picture. Okay, so we still can't save the game because we haven't given it a name yet. So let's say testing. Okay, so now, because we've added a valid game name, now this save button is enabled, and this tapping the save button is what will trigger these images to be uploaded into Firebase Storage. So let's try it. And before I hit save, I'm going to open up logcat. And as we upload images, we should see this log message in the create activity for the number of bytes that are uploaded, along with the progress, the status of how many images have been uploaded so far. Let's see if we can see those. Okay, awesome. So we can see that we have sporadically these log messages. Let's filter for create activity, because that's all we really care about. So you can see how the original width was a certain dimension and the scaled width is smaller because we're restricting the height to be 250 dp. This is logic that we wrote from before. Now we have 4 images that we're uploading. So you can see we have 4, we're seeing this uploaded bytes log message 4 times, which is great. And as we upload each image, we can see that the num uploaded goes up each time. Awesome. So now to validate that this properly worked, let's go back into the Firebase console and check Firebase Storage. We don't expect anything to change in Firestore, but in storage, we should hopefully have one extra directory in storage for this game. And that's what we see exactly here. So we have a directory called testing, and this should have 4 images. They're all prefixed by the current time in milliseconds, followed by the index, which is what we have here. And if you look at the preview, we're seeing exactly what we had uploaded, which is really promising. Awesome, that looks really good. And you can see kind of the rough size. This is around 14K, 4K, and about 2.7K. So this is really pretty small, so we're not actually eating up too much of the storage capacity in Firebase Storage. And it's also going to make our app feel a lot faster because we're downloading less data as well. And here's what the image looks like in the browser. In the next segment, we'll finish off the missing link of taking the image URLs that we have, along with the custom game name, and uploading that to Firestore. If you're enjoying this so far, hit that like button and subscribe so you get notified when the next part comes out. See you then.